In this video, we're going to add some additional textures and then create a few rendered views from Renderworks Cameras. First, we need to create a ceiling for our rooms. We're going to duplicate the existing floor slabs to create a ceiling for both the ballroom and the foyer. First, in the navigation palette, under the Design Layers tab, make the floor plan layer active. Select the ballroom and foyer slabs. Use the Alt or Option click in place shortcut to duplicate these slabs. Now switch to a left isometric view, and then render in OpenGL. In the Object Info palette, set the Z height to 20 feet, then click on the Class pop-up menu and choose New Class. Name the class Ceiling, and click OK. Switch back to a top plan view. Now let's import a few textures. We will access the Vectorworks libraries through the Resource Browser. In the Resource Browser, click on the Files pop-up menu and choose Vectorworks Libraries. Navigate to the Renderworks Textures folder, choose the Textures Interior Finishes file, and click Open. Locate the Paint Almond RT texture, then right-click or control-click on the texture and choose Import. Import the Ceiling Plaster LT RT texture as well. Go back to the Vectorworks libraries. In the Renderworks Textures folder, choose Textures, Metals, Plastic, Glass, and click OK. Now import the Metal Aluminum RT texture. Next, we will apply these textures to our objects using class attribute settings. Go to the Tools menu and open the Organization dialog. Under Classes, select the Ceiling class and then click Edit. Switch to the Other tab, enable the Texture Surface Hatch option, then click on the texture thumbnail. Choose the Ceiling Plaster LT RT texture from the list and click OK. Next, scroll down to the Truss class and choose Edit. Again, enable the Text Surface Hatch option under the Other tab, then choose the Metal Aluminum RT texture and click OK. Finally, edit the Walls class. This time, enable the left and right texture options under Walls. Then choose the Paint Almond RT texture for both the left and the right side. Click OK, and then OK again to exit the Organization dialog. Now, let's add a decal texture to the border on our exhibit booth tables. You will need the VW logo-white image. This can be found below the video in the Download section. Double-click on one of the exhibit table symbols. If you see a flipped symbol warning, click OK. Now choose 3D Component and click Edit. Go ahead and zoom in and then double-click on the table symbol and edit the 3D component. Switch to a right isometric view, then render in OpenGL. In order to edit the texture for the front of the border separately, we need to ungroup the soft goods object. Select the soft goods object, go to the Modify menu, and choose Ungroup. Click Yes to confirm the ungroup action. The soft goods object is now 3 separate NURB surfaces, so we can now map a decal texture just to the front surface. Select the front NURB surface. In the Object Info palette, click on the Render tab. Make sure the part is set to Overall VS Drape Texture, and then click Add Decal. Click Yes in the Change Texture Map dialog. In the Add Decal dialog, choose Import an Image File and click OK. Navigate to the VW logo-white image file, and then click Open. Name the decal Table Decal. Under Mask Options, choose Image Mask and click Choose Image. Select Reuse an image from another resource, then choose this decal's color and click OK. Under Source for Mask, choose Transparent Color and then click OK. In the Source Image Preview box, click on the black background of the image to choose the transparent color and click OK, and then OK again. Now let's map the texture on our surface. Activate the Attribute Mapping tool from the Basic palette. Click on the front NURB surface. Click and drag the decal to center it on the surface. Switch to the Scale Rotate by Center mode of the Attribute Mapping tool. Click on the upper right control point and move your cursor to increase the size of the decal. Click a second time to scale the decal. Now, center the decal on the surface. Press the X key twice to activate the selection tool and deselect the NURB surface. Now, render in Final Quality Renderworks to view the decal. Click Exit Symbol twice to exit the symbols. Now we will use the Renderworks Camera tool from the Visualization toolset to place a few cameras. Center your view over the ballroom, switch to the Visualization toolset, and activate the Renderworks Camera tool. Click once in the bottom left corner of the ballroom, behind the stage right seating layout. This point sets the location of the Renderworks camera. The next click sets the Look To point. Click once on the front midpoint of the curved stage plug. Now in the Object Properties dialog, click OK to accept the defaults. Now let's go ahead and adjust the field of view for this camera. The two outer lines that extend from the camera's insertion point show the field of view. We can use the control point on the left to adjust the angle. Switch to the Selection tool, click once on the control point, snap your cursor to the bottom of the stage right stairs, and click a second time to adjust the field of view. Let's take a look at the camera view now. Double-click on the Renderworks camera to activate it. Now render in OpenGL. Now let's go ahead and adjust the view of the camera slightly. In the Object Info palette, under the Shape tab, click on the Fine-Tune Camera View button. Set the camera height to 6 feet, and then click OK. Next, we're going to link this camera to a sheet layer viewport, and then render the view. First, make sure the Renderworks camera is still active, then go to the View menu, and choose Create Viewport. A pop-up will appear asking if you want to use the selected Renderworks camera for the viewport's view. Go ahead and click Yes. In the Create Viewport dialog, click on the Create on Layer pop-up menu and choose New Sheet Layer. Set the sheet number to Back of Paris Room. Go ahead and delete the sheet title. Then check the Edit Properties After Creation option and click OK. And then click on the Page Setup button. Choose a US ARC-C page size, then click OK. And then click OK again and once more to create the viewport. We now have a viewport on a new sheet layer that is linked to the camera. Let's adjust the scale and the render mode. In the Object Info palette, set the scale to 1/2 inch equals 1 foot. Now go down and set the background render to Final Quality Renderworks. Next, let's go ahead and edit the options for the viewport. First, we need to adjust the brightness of the directional light to make the room a little darker. Go to the Window menu, and then under Palettes, choose Visualization. The Visualization palette is currently showing the light settings for just the selected viewport, so any changes will only affect this viewport. Scroll down to the bottom of the list. The last light in the list should be the directional light. Right-click on the light and then choose Edit. Set the brightness to 45% and click OK. Go ahead and close the Visualization palette and then click on the Lighting Options button in the Object Info palette. For indirect lighting, choose Normal 4 bounces, then set the ambient lighting to 0%. Now enable the Ambient Occlusion option and click OK. Go ahead and click the Update button to render the viewport. When the render completes, we will have a view of the room and stage lit by our lighting devices. Let's create another camera view now for the Paris Foyer. In the Navigation palette, switch to the Foyer layer, switch to a top plan view, and then center the view over the foyer. Now, using the same procedure as before, place another Renderworks camera in the foyer. Place the camera on top of the Jack table symbol in the bottom left corner of the room, and then set the Look To point near the first 2 exhibit tables on the other side of the room. Now adjust the field of view. Move the control point to the inside of the left wall. Double-click on the camera, and then render the view in OpenGL. Click on the Fine-Tune Camera View button, and then set the height to 8 feet, and click OK. Now let's create a viewport. Go to the View menu again and choose Create Viewport. Click Yes to use the camera view. Under Create on Layer, choose New Sheet Layer. Set the sheet number to End of Foyer and delete the sheet title and click OK. Then click on the Page Setup button. Go ahead and choose a US ARC-C page size again and click OK in the 3 dialogues to create the viewport. Again, set the scale for this viewport to 1/2 inch equals 1 foot, then set the background render to Final Quality Renderworks. For lighting options, set the indirect lighting to normal 4 bounces again, and then enable the ambient occlusion option and click OK. Click the Update button to render the viewport. When the render completes, you may notice something odd about the exhibit tables. The Vectorworks decal is backwards. This is because these tables on the other side of the room were mirrored, so the decal was mirrored as well. Let's fix the decal for those tables. Go back to the Foyer layer, switch to a top plan view, select all of the tables on the right side of the foyer, go to the Modify menu, and then under Rotate, choose Flip Vertical. This will flip the table symbols and fix the backwards decal. Go back to the end of Foyer sheet and update the viewport to see the changes. Now we will create one more camera view of the exhibit booth. Switch back to the Foyer layer and go to a top plan view. Using the same procedure, place another Renderworks camera next to the first exhibit table on the right side of the foyer and set the Look To point near the front of the exhibit booth. Double-click on the camera and render an OpenGL. Click on the Fine-Tune Camera View button. Now set the camera height to 6 feet. Drag the camera distance slider to the left to move the camera a little farther away from the booth. Now use the camera pan slider to adjust the pan slightly to the right. Finally, use the camera move slider to move the camera to the left until the booth is centered in the view. Now click OK. Next, let's adjust the aluminum texture we applied to the trusses. Let's make the color a little darker. Locate the Metal Aluminum RT texture in the resource browser. Right-click or control-click on the texture and then choose Edit. Next to the color, click the Edit button. In the Edit Shader dialog, click on the Color pop-up and then click on the Standard Color Picker button. Use the Brightness slider to make the color slightly darker and then click OK. Now edit the Reflectivity shader, set the reflection to 60% and click OK. Click OK once more. Finally, let's create another viewport. Go to the View menu again and choose Create Viewport. Place the viewport on a new sheet layer. Set the sheet number to Exhibit Booth and delete the sheet title. Click OK and go to Page Setup. Choose a US ARC-C page size. Click OK, then OK again, and OK once more to create the viewport. Again, set the scale to 1/2 inch equals 1 foot. Let's use the same render settings as we did for the Foyer view. So set the background render to Final Quality Renderworks. Then for lighting options, set indirect lighting to normal 4 bounces and enable the ambient occlusion option and click OK. Now click the Update button to render the viewport. We now have 3 additional rendered views showing the ballroom, foyer, and exhibit booth. Before printing or exporting your document, you may want to go up and change the sheet layer DPI to 300 instead of 72. This will give you a much better quality for print or export.